Welcome back. In this session, we are going to learn the real magic behind Docker. How to run your first container, what exactly a container is, how to connect to it, and finally, how to host your own website inside Docker. By the end of this lesson, you will be comfortable using Docker commands and truly understand what's happening behind the scenes when you say Docker run. Let's start with the classic first step, running Hello World in a container. I have already published a simple Docker image called Hello Docker. We just print a greeting and some system information. Let's run it with this command. The moment I press enter, Docker checks if the image is available locally. If it is not, it downloads it from Docker Hub. We call this process pulling an image. Once the image is downloaded, Docker creates a container out of it and runs it. You will see the output saying something like this. Every time you run the same command, you will get a new container with a new host name and possibly a different IP. That's because Docker creates a fresh isolated environment each time. Simple, right? But what just happened here? Let's unpack that. A Docker container is like a box that holds your application and everything it needs to run. The code, libraries, dependencies, and environment settings. Inside that box, the app thinks it's running on its own computer. It has its own hostname, IP address, and file system. But here is the cool part. All of that is virtual. Docker is actually sharing your computer's operating system. So, while each container is isolated from others, they all use the same CPU, memory, and operating system kernel. This gives Docker its two superpowers. Isolation. Apps don't interfere with each other. Density. You can run many containers efficiently on the same machine. Compare that to traditional virtual machines, where every VM needs its own full operating system. Containers, on the other hand, are lightweight. They start in seconds and use far less memory. That's why Docker has become the go-to choice for developers and DevOps teams everywhere. Now let's go a step further. Instead of just running a container that prints output and exits, let's actually connect to it like a remote computer. To do that, we will use the interactive and TTY flags. This command gives us a terminal session inside the container. Now, if I type host name, I will see the container's unique name. If I type date, I will get the container's internal clock. And just like that, I am inside an isolated environment, yet it's running right on my laptop. You can open another terminal and list your containers. It shows the container ID, image, command, and status. To check what's running inside or to see logs, when you are done, just type exit and the container will stop. Remember, once the process inside the container ends, the container itself stops too. Let's host a website using Docker. Here is the command. The -d flag means run in detached mode in the background. The -flag maps port 8080 on my computer to port 80 inside the container. When I open my browser and go to http localhost 8080, Docker forwards my request into the container and the container responds with my website. That's how Docker makes networking simple. It routes external traffic into containers using port publishing. You can monitor the container's performance using Docker container stats. And when you are done, Docker container remove. Just like that, your web server is gone. No manual setup, no leftover files, no headaches. So, how does Docker actually do all this magic behind the scenes? There are two main components. Number one, Docker engine, the brain of Docker. It handles image downloads, container creation, networking, and storage. It runs as a background service on your computer. Number two, Docker CLI, the tool we use to type commands. It's just a client that talks to the engine using a REST API. The engine also relies on an open source runtime called containerd, which in turn uses your operating system features to isolate containers. This architecture is what makes Docker cross-platform. The same command works whether you are on Windows, Linux, or Mac OS. And since Docker follows Open Container Initiative standards, your apps are portable. That means if you build an image on Docker, you can run it on Kubernetes, Podman, or even another cloud platform. In this session, we explored Docker in action. We ran our first container, connected to it, hosted a website, and learned how Docker really works behind the scenes. You now understand that Docker is not just a tool. It's a complete platform that simplifies development, testing, and deployment. In the next module, we will go deeper. We will learn how to build our own Docker image from scratch using Docker files. See you in the next module.